Hello, and thanks for using TickBoom. In this video, I'm looking at question 1 of the 2020 Board of Studies Extension 2 trial paper. So I answered a question from this paper last year, question 11D, and the student who sent that through then followed up asking if I could work my way through the rest of the exam. Now, interestingly, the Board of Studies, they release a trial paper each year, and typically their papers are on the harder end of the spectrum, so they're very good practice if you want to get exposure to what harder questions may look like in the ultimate HSC exam. But they do also release answers. So the exam that I'm about to work through, there are answers out there, but it's often the case that even with the answers, some students still struggle to understand why a certain question is the way it is and why the answer is what it is. Sometimes the written solutions, they may skip over steps, or they may assume that you know things when perhaps you don't. So sometimes it can actually be helpful to have a solution worked out from scratch. So you start from a blank piece of paper and you just kind of build up the solution so that you can see it all as it plays out and have it explained. So essentially what I'll do is I'll work through all 16 questions of this exam one at a time. Naturally, I'll start here at question 1, and hopefully through my explanations, hopefully that'll be a good complement to the written solutions, and hopefully I'll be able to be helpful in getting students to kind of wrap their head around these questions. So this first question is to consider the vector equations of the lines below. So we've got r vector, we've got it written out in column form here. So we've got 1, 2, 5 plus lambda times 2, 4, negative 3. And then we've also got this other vector, also called r vector, which is 2, 3, 2 plus mu 4, 8, 1. And the first thing I noticed reading this is that both of these lines have been given the same name, r vector. I wasn't sure the significance of that. In the end, I don't think it matters. You can still kind of work out this question. But I did find that confusing. I'm not sure the reason behind that. I'd be interested to know if anyone kind of knows why both of these lines have r vector. Please feel free to comment and let me know, because I may be missing something there. But in any case, with these two different vector equations, we need to pick the correct statement. So we've got 4 options here. We've got either the lines are parallel with no point of intersection, the lines are not parallel with no point of intersection, the lines are parallel with a point of intersection, and the lines are not parallel with a point of intersection. So basically we're asking, are the lines parallel or not parallel? And then we're asking, is there a point of intersection or not? And then once we answer those two, we can combine them to effectively pick the correct option. Now, this is a multiple choice question. When I did the HSC, there weren't these multiple choice sections in the exam. All the questions were that kind of long answer format. Since I took my exams, they kind of changed the system so that all the mathematics exams seem to now have these multiple choice sections. I'm not quite sure what the rationale was behind that, because on the surface it kind of looks like you're introducing an element of chance now. You know, there could be some questions where students don't have a clue what to do, yet they've still got a 25% chance of picking up a mark. So I'm not quite sure what the point of that was. But in any case, basically, when faced with these kind of multiple choice questions, you can essentially use a process of elimination. You know, we'll work out, are they parallel or not? That'll then chop out 2 of these options, kind of reducing it to a flip of a coin, a 50-50 chance, and then hopefully we can then work out whether there's a point of intersection to then get the answer. So I do find it interesting that these exams now have these multiple choice. I don't know if that is for the better or not, but in any case, it is what it is. So here I've written up our two vector equations and the four options that we've got to choose from. So the first step will be to ask the question, are these two lines parallel or not? And I think to answer this we can look at the direction vectors. So if we look at these two vector equations, we can think of the first column of each being the position vector, and the second column as being the direction vectors. And basically two vector equations will be parallel if their direction vectors are multiples of each other. So one way we can think of that would be, can we say that the first column 2, 4, 3 is that direction vector equal to some multiple, I'll just use m for multiple, of 4, 8, 1. And if we just work through each row one at a time, each row of these columns, if there's a consistent multiple m here, then we can say that they're parallel. So for this first column, 2, well, what would m be to get 2 from 4? M would be equal to a half, since 2 is a half of 4. For the second row, m would also be a half, since 4 is a half of 8. But for the third row, m would be negative 3. Since to get from 1 to negative 3, you have to multiply by negative 3. So whilst we had the same scaling factor in the first two rows, we didn't for the third row. So because there wasn't this consistent multiple that we could apply, we can say that these two vector equations are not parallel. So we can now kind of strike out the two options that involved parallel, and now we're down to just having to pick from two options, and we need to work out, is there a point of intersection? So I think to deal with this question of is there a point of intersection, we can just try and find the point of intersection and see. If we do get one, then there is a point of intersection. If we can't get one, then there mustn't be. So the way we could find the point of intersection would be to equate each of these row components of the vectors. So we'd have 1 plus 2 lambda being set equal to 2 plus 4 mu. I'll call that equation 1. We'd have 2 plus 4 lambda being set equal to 3 plus 8 mu. I'll call that equation 2. And we'd have 5 minus 3 lambda being set equal to 2 plus 1 mu. And I'll call that equation 3. Now, we've only got these two unknowns, so we really only need two of these three equations to kind of solve for the point of intersection. I think these first two are the natural ones to use, because you can kind of see just by observing that the left-hand side of equation 2 is double the left-hand side of equation 1. So if I take equation 1 and multiply it by 2, then what I'd get is 2 plus 4 lambda is equal to 4 plus 8 mu. And I'll call that equation 4. And then if I do equation 4 minus equation 2, what I'll get is 2 plus 4 lambda minus 2 plus 4 lambda is equal to 4 plus 8 mu minus 3 plus 8 mu. So on the left hand side here I'll get 0, and on the right hand side I'll get 4 plus 8 mu minus 3 minus 8 mu. So the 8 mu's will cancel and we'll just have 4 minus 3 is equal to 1. 0 is not equal to 1, that's false. So therefore we can't get a point of intersection. So therefore there's no intersection. So that means we've got the equations, the lines are not parallel, and there's no point of intersection. So that means option B is the right option. So that's the way to go about this question. As I mentioned, being multiple choice, it really is just a process of elimination. So here the key was just to kind of work systematically through the two different points that we were considering. Are they parallel or not? What is the point of intersection, if any? So hopefully that's made sense and you've been able to follow along with that. And tick boom.